So talking about the factors affecting the rate of a chemical reaction, we've defined the rate of a chemical reaction to be, looking at how fast um, the reaction progresses. In other terms, we broke it down to be the changes, the rate at which the concentration of the reactants or products change in a chemical reaction, the rate at which we observe that change, or how fast the concentration changes of reactants and products. Okay. Now there are certain factors that affect how fast the reaction will progress. Okay. So what are the things that we want to talk about now in terms of gi- giving reasons or trying to describe how the factors affect the rate of a chemical reaction? I usually like basing them, and of course, it is a requirement that you base them on theories. That way, it makes more sense. So I'll use the collision theory. I know you already know the factors that affect the rate of chemical reaction. Now, the point here is they may not even ask you to state. And if they ask you to state, of course, they just have to ask you to explain how they affect. So, collision theory, just what is this? So, collision theory is basically an idea that for a chemical reaction to progress, particles must collide with sufficient energy. So, I want you to write that down. Particles must collide with sufficient energy. So what have I said? So I've said that for a chemical reaction to progress, particles, now these particles are particles of the reactants. So for a chemical reaction to progress, particles of the reactants must collide with sufficient, the last part there is energy. Of course, that is going to be talked about later. What is what we call the activation energy, the minimum amount of energy required for a chemical reaction to basically go on. So there is need, but for a reaction to be successful between reactants, let's say and B, their particles must collide with sufficient or enough or minimum energy. Okay. So if we are to increase the rate of a chemical reaction, then we need to basically do something that is going to support the successive collisions between the particles of the reactants. Okay. The other way you can think about it is we have what we call kinetic theory. So kinetic theory, you can try to research more about that. So kinetic theory basically tells us that as we increase the kinetic energy of the particles, so increasing the kinetic energy of the particles, the increase in the kinetic energy of the particles increases the temperature of the particles. So I don't know how I'm supposed to put it. If it's either the temperature or an increase in temperature reach to, but we can think about it in this way. So an increase in the temperature is an increase, or we can define temperature to be the increase in the kinetic energy of the particles. Yeah. So as you increase the temperature, the kinetic energy of the particles basically get to increase. Okay. So basically, talk about this in terms of temperature as a factor that affects the rate of a chemical reaction. So using these two theories, we should be able to, of course, not stating them, it's not a necessity, but in terms of relating them to the rest of the chemical reaction, we should be able to give reasons. So some of the factors that are very important, the common ones, the very ones that you know of, include temperature. So what is temperature? So temperature is the average kinetic energy of the particles, which I've already defined. Okay. So how does it affect the rate of a chemical reaction? So it's very simple. If we are to understand how a temperature affects it, of course we understand that if you increase the temperature, the rate of a chemical reaction is expected to do what? To increase. Now, we need to give a reason why. We need to account for that. So using the kinetic theory, we've seen that an increase in the temperature is an increase in the kinetic energy of the particles. So we are trying to say that the temperature increases, the rate of the chemical reaction increases. Now why? Because an increase in the temperature according to the kinetic theory, so an increase in the temperature increases the kinetic energy of what? Of the particles. So now remember that according to the collision theory, particles must collide and then with sufficient energy. So this actually increases the probability of what? So increasing the kinetic energy of the particles means they are moving now what? Particles tend to move faster. So if they move faster, what happens? The likelihood of the collisions increase, or more collisions occur, leading to more successive collisions, leading to the reaction taking place. Because we are saying, according to collision theory, to say we need particles to collide, and they should collide with sufficient energy. So if we increase the temperature, we increase the kinetic energy of the particles, which means they tend to move faster, leading to more successive collisions between the reactants. Okay. Now, of course, the opposite is true. If you reduce the temperature, you are reducing the kinetic energy of the particles. The particles will move less and slower, leading to fewer successive collisions between the particles, and so the rate is low. The most important of all that I was supposed to start with, which relates more to the collision theory, is the concentration of the particles. Instead, let me use the word reactants. So the concentration of the reactants. So we've said that we want more collisions for the reaction to basically progress. So what happens if you increase the concentration of the reactant? So you expect that after increasing the rate, the concentration of the reactants, even the rate of the chemical reaction is going to increase. Why? Because an increase in concentration means more particles, and more particles means the likelihood of colliding is more. So the concentration of the reactants basically affects the rate of the chemical reaction. The higher the concentration, the higher the probability of the particles colliding, leading to a higher rate of the chemical reaction because of more successive collisions because of the particles' higher concentration. Lowering the concentration of the reactants, the probability of the particles colliding is less. And the other thing that affects is surface area. So I know I've been making videos about surface area, but I basically don't even I don't have a formal definition of surface area. But the way I understand surface area is like if you think about salt, salt is very tiny, right? And then think of something. Now imagine salt was like in form of course, some of us have seen the salt where it is like not in crystal form, where it is like in blocks like this. Okay. So what I want you to understand is the salt that is in crystal form has got higher surface area. Okay, higher surface area. Then this one, which is in blocks, is actually has got a lower surface area. So now the question is, what do you think if you are to try to dissolve the two, which one would dissolve faster? Taking that as our reaction. So you understand that the one with the higher surface area, which is smaller, is basically going to lead to more successive collisions. Now, why am I saying so? I'm saying so because we are trying to support the collision theory. So you can think of both reactants to be that small. So they'll be able to what? They'll be able to collide more successively as compared to the parts where they are bigger. Because remember, particles are small, so they are actually making up the blocks that we've written there. Now, in the case where something is bigger, the outer area of encounter is limited. Okay, so the higher the surface area, the higher the rate of the chemical reaction. Okay, that's what you need to understand there. So the higher the surface area of the particles, the higher the probability of the particles basically getting to collide with one another. So this usually deals with solids, as you've seen in my description. So that deals with solids. Now, in terms of gases, pressure also does affect. Okay, I know people pressure is like force over area. Okay, so pressure. So this deals with gases. So the higher the pressure, so the relationship that is there between pressure is that pressure is inversely proportional to volume. The higher the volume, the lower the pressure. So if you've got something, a container like that, and then you've got another container like that, and then you've put two different gases inside the two containers, where do you expect that there will be higher pressure? So you need to have higher pressure in a container where it is smaller if you put the equal number of particles. Where so in the bigger container, the chances of the particles colliding are slim. So what you're going to say is the higher the pressure of gaseous reactants, the higher the number of collisions. The reason is simple. Pressure is higher when the volume is reduced. Okay, so more collisions. So if you can think of pressure to be as a result of collisions between the particles or among the particles. Okay. So basically these are the factors that affect the rate of a chemical reaction. Okay, you can try to research for more, but these are the major ones. Okay.